Assalamu alaikum kids. Today we're discussing the factorization of type 4, page number 134. This has a general shape of ax square plus bx plus c, ax square plus bx plus d, in which you can easily notice that ax square plus bx is common in both of the brackets. And then there are two brackets in which the first two terms are same, but the third term in both of the brackets are different from each other. And then there is a number that is added later out of the brackets. This is the general shape of these type of factorization. So let's see how to factorize it. X square plus 7x plus 10. Let's see how to factorize it. It's mentioned x square plus 7x plus 10. This is example number 14, page number 134. X square plus 7x plus 12 and then plus 1. Let's see how to factorize it. I can see, let's start solution, and this is a general form of solving a question. We write it again as it is, the whole question. Then I will say that let the common term, this term, which is common in both of the brackets, let's take it equal to y. Let's name it y. X square plus 7x is equals to y. So it implies that y plus 10, this thing is replaced with y, and 10 is here at its own position. Then it's y plus 12 and plus 1. These two terms are replaced with y, and 12 is written with it as it is. Then I will say, okay, since there is no equal sign in it, so I will not write implies, rather I will write equal in it. So it's equal to, when I multiply both of them, y square into y is y into y square, y into y is equals to y square, then plus y into 12 is 12y, 10 into y is 10y, or 10 into 12 is 120. This one remains the same, isn't it? Or I can say that y square plus 22y plus 120 plus 1 becomes 121. So I can easily say that I can write it in the form of a perfect square or a complete square. This is of that shape in which we say that this is equal to, that this is a perfect square. Or I will say a plus b whole square is equals to a square plus 2ab plus b square. So this is your a square plus 2ab plus b square. So I will say this is equal to y or a plus b and whole square. This is equal to a plus b whole square. Now let's put back the value of y, that is x square plus 7x as mentioned earlier. So I will say x square plus 7x and then 11 remains the same. This is the value of y, and 11 remains the same. So I can say that this is the value of y, or this is the factorized form of this question, this type. Now how do I understand that this is, since the answer includes brackets, and this is also written as a product of two brackets. So how do I say it is factorized and it is not factorized? Let me tell you, these two brackets are in factorized form if there is no plus 1 in it. But since there is a plus 1 out of the bracket, so I can say that I can factorize it further. So now we factorize it further, and now I don't have anything out of the bracket here. I don't have anything out of the bracket, rather I have everything factorized inside the brackets. So that is your answer. Now let's discuss another type. That is, let me show you here in the book so that we can solve an example. This is factorization of the type 4, and this is containing 4 brackets in it: x plus a, x plus b, x plus c, x plus d plus k. Then there are 4 brackets which are in completely factorized form if there is no k with it. But I can see a k here, so it is not factorized, and I can factorize it further. So let's factorize a given example: x plus 1, x plus 2, x plus 3 and x plus 4 plus 1. Plus 1 is out of the bracket. So let's see how to solve it. Your example is x plus 1, x plus 2, x plus 3, x plus 4, and this is plus 1. I think it's like this. Yes. And this is your example number 16. So I have to just pair them up. And how do I pair them up? I need to know that the numbers mentioned in the brackets should be equal when paired up. Like 1 plus 2 makes 3, but 3 plus 4 makes 7. So they are not equal. So 1 plus 3 makes 4. If I say 1 plus 3 makes 4, but 2 plus 4 makes 6. So they are not equal. Then I will say 1 plus 4 makes 5 and 2 plus 3 makes 5. So I will pair them up in the same way. So let's rearrange. I will say rearrange x plus 1 with x plus 4, since 1 and 4 makes 5, and x plus 2 and x plus 4 makes this is x plus 2 and x plus 3. So 2 and 3 makes 5 and 1 and 4 makes 5. So let's solve them. Let's solve these two brackets. When solving, these will give me x square plus 4x plus 1x is 5x and plus 4. It gives me like this. And this is exactly the same, x square plus 5x. The first two terms are the same, and 2, 3 are 6. So this is 6 and this is plus 1. Now it has the same method. Let the same terms equal to y. Let x square plus 5x is equals to y. Then it is equal to y plus 4. This 4 remains the same, and these are named as y. Do you understand that? The second bracket opens and these two terms are named as y, and this 6 remains the same, isn't it? So now let's open them up. This is y square. Let's solve these two brackets with each other. So y square plus 4y plus 6y is 10y, and plus 6 4s are 24, and plus 1. It's like this. So now I can say that y square plus 10y plus 25, and then I have to solve them up. So 25 and y square plus 10y plus 25. Y square plus 5y plus 5y plus 25. I can write it like this. Y is taken common, y plus 5 is inside the bracket, then plus 5, y plus 5 is in the bracket, remained. Then I will say y plus 5 is common. These y plus 5 is common, so taken once out of the bracket, and then what is left? Y plus and 5. Y plus 5 is left. Or I can say that it is y plus 5 whole square. So let's put back the value of, y is equals to x square plus 5x, like this. So I am given x square plus 5x and plus 5. This y is replaced with its value, and 5 remains the same, and this is the square. So this is your answer. This is how we solve it. So it's now completely factorized, and nothing, no digit is out of the bracket. No digit, no term is out of the bracket. Everything is bractified, and it is inside the brackets, properly factorized. So these are the two types mentioned today. Inshallah, we'll be discussing this third type, the fourth type and the fifth type, inshallah, in the next video. This is for now.